All right, let's start at the beginning. We have a radicand, and we're being asked to make this substitution over here. Let's just do that first. All right, so it's going to be 16 minus 3 times that substitution x, which is 4 sine theta over root 3. All right, let's just do that. What do you get? 16 minus 3 times 16 sine squared theta. And then you get, let's see, 3 on the bottom. That's not so bad. And what do you get there? You get 16 minus the 3's cancel, 16 sine squared theta. 16 comes out. You get 1 minus sine squared theta. And what about that? That's pretty simple identity. You should be aware of that. That's just the cosine squared theta. So I understand why they did it. Let me write this down for you. So it's going to be, I'll put a little star here because I'm making a substitution. It's going to be 16 cosine squared of theta. Now, I'm going to say that that's understandable, but now I got this dx business. I'm going to start to erase things now. I'm done with this. And I want to put the dx down. All right, what's dx going to be equal to? Well, dx is going to be 4 over root 3 times, root of sine is cosine theta d theta. All right, so I'm going to write that down. That's going to be 4 over root 3 cosine theta d theta. Now, granted, a lot of students look at it and say, it just got so much worse, it's ridiculous. It didn't get worse. All right, it did not get worse. All right, I'm going to erase this over here. I'm done with it. I'm going to simplify it. Before I do that, though, I want to point out, for the sine function, the invertible region of it, we pick the numbers, and this is something you learned in Math 120, your pre-calculus course, between minus pi over 2 and pi over 2. Now, I say you learned that, you also learned a justification for picking that region. What's nice about that, the cosine curve there is non-negative. So what do we really get over here? Let's write this down, and carefully. You get 4, because the square root of 16 is 4. The square root of cosine squared on that interval is cosine theta, not to worry about absolute value, times 4 over root 3 cosine theta d theta. I'm going to rewrite it. That's going to be 16 over root 3, and that's going to be cosine squared theta. Well, sort of deja vu all over again. And what I mean by that is I'm looking at the cosine squared and I realize I need a double angle formula again. It's not that we've seen in the past. So let's write that down. The cosine of 2 theta is 2. There's 3 different identities for it. I'm going to use this one over here. That means cosine 2 theta plus 1 over 2 is cosine squared theta. I'm going to write that down now. What do you get? 16 over root 3. Cosine squared is going to be cosine of 2 theta plus 1 over 2, and then I got the d theta. All right, I'm going to keep moving, and I'm going to pull out the 2 on the bottom, so it's going to be 8 over root 3, and then we get a star, and then I get cosine 2 theta plus 1 d theta. Well, I can definitely integrate that, so things did get simpler. The nth derivative of cosine 2 theta is going to be sine of 2 theta. But remember, if you differentiate that, you get a 2, so I got to remove that, then plus theta, plus some constant of integration. Now, what happens to a lot of students now is there's a lot of work. They forget why they've done this. And the main reason to do this over here is you got to go back to x's now, right? So what do you get over here? I'm going to multiply it out for you a little. Maybe not. Let me just do a little bit of work, not too much. The sine of 2 theta is 2 sine theta, cosine theta. That's over 2 plus theta plus c star. What do you get over there? 8 over root 3. Then you're going to get sine theta cosine theta plus theta. That's theta plus c. That's a star. All right, let's remind ourselves what the x is. X is equal to 4 sine theta over root 3. All right, so let's just solve for the theta. So it's going to be, that's what the x is, right? So let me just see if I said that right. x is 4 sine theta. Yeah, I did okay. So what's sine theta going to be? Let's write this down. It's going to be root 3 x over 4 is equal to sine of theta. All right? So let me just make sure I did that right. Multiply by root 3 divided by 4. Yeah, I did okay. I'm going to do a little triangle over here. This helps me out a little bit. This will be theta, and the sine of theta, this is going to be root 3 x, this is going to be 4. This will be Pythagorean theorem, 16 minus 3x squared. All right, let's write this down. This is going to be 8 over root 3. Sine theta is going to be root 3 x over 4. The cosine of theta, I'm looking at this picture here. You know what? I made a mistake in the picture, and I'm going to correct it now. I'm daydreaming. And this will be, let's see, 16 minus 3x squared. Sorry about that. The cosine theta is going to be the root of 16 minus 3x squared over 4 plus theta. I'll clean this up in a moment, by the way. What's the theta? It's going to be arc sine of root 3x over 4 plus some constant. Let's just clean it up a tiny, tiny little bit. And let's take a look. I'm going to take this and distribute it against the first term. Well, 4 times 4 is 16, and 8 goes to 16 2 times. All right, so again, 4 times 4 is 16, 8 goes into 16 2 times. Root 3 disappears. We're left off with x root 16 minus 3x squared. That's done. Let's do the next term. It's plus. It's going to be 8 over root 3 arc sine of root 3x over 4 plus c. I think we're done. All right, put a little line over here, get a little red pen out, and see how we did. Did we get the first term, which is x? Yeah, I think I got that. Yeah, I did it right. I think I got this. Yeah, I did it right. Did I get this? Yep, and I got the C. We're done. Now, granted, I know my chicken scratch looks like chicken scratch. There's really nicely typed up work over here. I'm not looking at that carefully, though. You might want to look through it and certainly make comments on it. If you think there's an error somewhere, bring it to my attention. Thank you.